Welcome to SJCE content. I am Dr. D. Shobha, working as Assistant Professor in Department of Physics, St. Joseph College of Arts and Science, Kadalur. In this video, I am going to teach surface tension. Surface tension is the basic properties of liquid. It is a basic property of liquid. This basic property tend the liquids to acquire minimum surface area. In order to acquire a minimum surface area, a liquid must experience some kind of force. That is a contracting force. Any liquid in small quantity acquire spherical shape. Because the gravity influences us here negligibly small value, but a big liquid flatten out due to its weight. We can explain it. A small liquid means we consider a tap. If you release the tap slowly, the liquid flows from the tap as a small droplet. These droplets have the spherical shape. That is, a small quantity of liquid acquire the spherical shape. Why we are getting a spherical shape means the gravity influences negligible. Whereas, again consider a tap. If you release a large number of water, a big quantity of water from the tap, it will flow like a flattened liquid. Here, the gravity influence is not negligible. So hence, a small liquid will acquire a shape of a spherical shape. A big liquid get flattened out due to its weight. Let us see some experiment how the liquid decrease its surface area. Consider a liquid tank in which we dip the brush . This is a brush, water tank. This is the bristles. When you dip the brush into the liquid, what will happen? The bristles are spread out. Inside the liquid, the bristles of the brushes are spread out. When we taken out the brush from the tank, the bristles get clink. The bristles cling together on account of the liquid surface contract the bristles. So this is the example. For this example, illustrate the surface area of the liquid will contract the bristles. Next we will see the definition of the surface tension. So in the liquid surface, the surfaces of the liquid acts like a stretched membrane. The surfaces of the liquid acts like a stretched elastic membrane. This membrane have the tendency to contract the bristles. So we have the definition for surface tension. The surface tension usually represented by the symbol sigma. It takes the form force acting per unit length. So how to define it? Force acting, it is defined as force acting on the line drawn on the liquid surface acts perpendicularly to it at each point and tend to pull the surface apart. So this is the definition for surface tension. It is the force acting per unit length on a line drawn on the liquid surface and act perpendicular to it at each point and tend to pull the surface apart. Consider this is a liquid surface. In that surface we are drawing a line. In that line we have so many points present on it. Here the force is acting perpendicular to the line drawn on the surfaces of the liquid. This force is acting perpendicular to the point and this forces tend to pull the surface apart. So it will look like a stretched membrane. Next we are going to see the unit of surface tension. So surface tensions take the formula sigma equal to force acting per unit length. We have the unit for force is Newton and unit for length is meter. So the surface tension get the form unit Newton per meter. This is the unit for surface tension. Next we will see the dimension formula. Dimension formula for surface tension. So surface tension takes the form, it is the ratio between the force per unit length. So dimension of force, dimension for force equal to, dimension of force F equal to ml t power minus 2. We know that F equal to mass into acceleration. Mass takes the dimensional formula m. Acceleration we have L t power minus 2. So force has the dimension of L t power minus 2. The dimension of length equal to L. So on substituting, we get force as the dimension L t power minus 2, length is the L get cancelled, so we have m t power minus 2. This is the dimensional formula for surface tension.